Good evening, Bearcats. This is going to be on 1.4 functions and 1.5 on analyzing graphs. We're going to start with 1.4, talk about some very basic things about relations versus functions. I want you to go to page 48 in your textbook, and I want you to answer basically yes or no to the first 8 problems on page 48 about whether something is a relation, inner function, and how they relate. The definition is here for you that should help you with that. The next thing I want to do is I want to talk about independent and dependent variables, and I'd like for you to go over to the side in your notes after you write these 2 columns down, and in the 3rd column I would like for you to give me maybe an example, whether that's a list, whether that's a graph, but I'd like for you to show and label the independent and dependent variables for me. All right, the next thing I want us to do is I want to talk about, and at any point along the way, of course, you'll pause and take care of what you need to. The next thing I want to do is talk about a test for functions to determine if y is a function of x. And that is the verbiage, that is what you're going to hear or see in the question on a test. Those are the kinds of words that you're going to use. So you're going to determine if the y is a function of x. And we're going to do that, and we're going to test to see what that looks like. And I also like to use a sketch. The vertical line test is a really good test for testing for functions, something that you're familiar with. So don't forget the vertical line test. Of course, remember as you move that vertical line across a particular graph, if is the visual, and it crosses that graph at more than one y value, then you do not have a function. All right, let's take these 2 examples and work these together. Again, you will have something similar on your test and in some classwork that we're going to do. So the first one, x squared plus y equals 1. We're going to solve for y. So you're going to solve for y. When we do that, you'll end up with y equals negative x squared plus 1. Y equals negative x squared plus 1. Well, let's just take a look at what that is. That's actually just a quadratic that's going to turn down, and it's going to be moved up. The vertex will be shifted up 1. So our graph is going to look something like this. And of course, I'm going to just kind of sketch in with a vertical line there. If you had a vertical line going through that graph, of course, it'd only fall under one place. So yes, we have a function. Yay, go Bearcats. All right, the next one let's take a look at is negative x plus y squared equals 1. So let's take a look at that and solve for y. So we solve for y, we get y squared equals positive x plus 1. And then we want to clear out our squares, so we're going to take a square root. Now, we talked about this maybe in your class. If not, I want to refresh your memory. We just drew in that radical sign, that square root. Because we were the artist of that square root, we're going to sign our artwork plus or minus. And that's just a reminder to you on when to put your plus or minus. So if you actually interject while solving a even root, then you're going to have that little plus or minus in front of it. So we're going to have y equals positive or negative square root of x plus 1. Square root of x plus 1. All right, well, I'm just going to go ahead and graph this real quick. Just sketch a graph, and you can just plug in information. So we're going to keep everything positive to begin with, and I'm going to plug in 0. Well, 0 plus 1 would be 1. And let's go ahead and put in negative 1, and 1 would be 0. Now, here's the interesting thing. You know by transformation this would shift to the left 1, and there's our vertex point. Or, sorry, in this case, there's our end point. If we added 2, you're going to go to 3, and it's going to keep going up, and your graph is going to look something like this. Now, we're going to take those same values, but we're going to take all the negatives, or the opposite signs of that. So when I plug in negative 1, my output is still 0. But when I plug in 0, my output is now negative 1. Okay, and so you're going to do the same thing, and your graph is going to end up looking like this. I'm not doing a very good job at my graph. It's going to look like this. All right, now think for just a moment. Will I pass the vertical line test? Nope, I will not, so no. This is not a function. All right, beat Katie. Okay, if you're back with me, we're going to go on to the difference quotient. The difference quotient is a really, really big principle that we're going to use in one of the definitions in calculus, and this is the ratio of the difference quotient. So I've written that down, I've written an explanation about it, and I've given you the ratio. So now let's go ahead and work a problem together. You will have to do this also on your test and in some classwork tomorrow, so make sure that you're paying close attention. We're going to work the following problem. So we're going to go f of x plus h. So think of this f of x was f of x plus h. You would plug x plus h in for both of the x's, and that's the first thing we're going to do. So we're going to go over here and we're going to go x plus h, and then it would be squared minus 4 times x plus h plus 7. And then you're going to subtract, and be really careful. Since we're subtracting, I'm going to put a parenthesis so I don't forget to distribute f of x. Well, f of x is simply this equation, x squared minus 4x plus 7. And it's all over h. All right, now that's the hard part of substituting into the formula, and now it's just cleaning things up. If you have forgotten, there is a shortcut to binomial squared. If you have a binomial squared, I'm just going to go over to the side here, and it's squared. Remember, you can square the first term, you can square the last term, and you can multiply everything together to get the middle term. So 2 times x times h, or 2xh, and since that's positive, everything would be positive. So that's a way to shortcut that, and I just wanted to kind of do that as a side note. So we're right here at the top, then we have x squared plus 2xh plus h squared. Then we're going to distribute this negative 4 and get negative 4x and a negative 4h plus 7. And then we're going to distribute this negative all the way through and get negative x squared, a positive 4x, and a negative 7. And of course, all over h. If you need to stop and pause and, take care of that, do. All right, now let's just do some cancellations. This all comes out really nice. We have a positive x squared and a negative x squared that cancel. Let's see, we have a positive 7 and a negative 7 that cancel. We have a positive 4x and a negative 4x that cancels. And I think that's where we end up. So let's think now what we have left. So we have 2xh plus h squared minus 4h all over h. All right, in the numerator, I have a common term, h, so I'm going to factor that out. So I'm going to take an h out. I don't have anything else in common, and I get 2x plus h minus 4 all over h. Those h's actually will cancel, and my final answer then is 2x plus h minus 4. With the restriction, be careful because you had a fraction, so with the restriction that x could not equal 0 in this case, and that is your final answer for the difference quotient. So pause and take a look at this. Make sure you understand it. It will come up tomorrow. Next, let's talk a little bit about a piecewise function, and let's go ahead and graph it first, and then we'll go back and evaluate. I want to make sure you can graph first. Remember, a piecewise function could be multiple functions or parts of different types of functions, and they're restricted. There's a restriction on the domain. In the first case, we have a restriction that all the x values have to be less than 0. So you're always going to start with what's given, 0. If I plug in 0 into this equation, I would get 0 squared is 0 plus 1, I would get 1. So 0, 1 would be my starting point, 0, 1. But because it was not equal, I'm going to put an open circle at 0, 1. Then I have to pick values less than 0. So I'm going to pick negative 1. Negative 1 squared is 1. 1 plus 1 is 2. So at negative 1, I'm at 2. And I'll pick one more value. Let's just pick 2. So negative 2. Negative 2 squared is positive 4. Positive 4 and 1 is 5. So at negative 2, you're up here at 5. And so this is part of a quadratic. It looks something like that. All right, and then next I have x minus 1. That's a linear equation, so it's part of a line where our x values are greater than or equal to 0. So again, we start with 0. 0 minus 1 is negative 1. So at 0, we're at negative 1. Now in this case, I'm going to put a solid filled-in dot because it is equal. And then since it is a line and the slope is 1, I could probably just do that. But if you want to plug in a couple more numbers, you can. Let's just plug in 2. 2 minus 1 would be 1. So at 2, we're at 1. And let's plug in 4. 4 minus 1 would be 3. So at 4 would be at 3. And it looks like you just have a slope of 1. So it looks like you'd be on each of those points. So my graph would go off like this. All right, there's the graph. Now let's evaluate. Let's evaluate looking at the graph, actually. You could have plugged in, and you would have to make sure you plugged into the correct equation. So when it says negative 1, you would have to plug into the first one because x is less than 0, which includes negative 1. And then the 0 and the 1 would be included in the second one. But let's also just look at the graph. At negative 1, we're at 2. At negative 1, we're at 2. So when x is equal to negative 1, f of x equals 2. When x is at 0, that's open, so we're going to go down to the closed dot. We're at -1. So when x is equal to 0, f of x is equal to -1. And finally, with 1, 1 is x equals 1, f of x looks like it also equals 1. And that's how you would solve a piecewise or evaluate a piecewise function. Again, this will come up, so make sure you have it written down. Go Bearcats. All right, next we're going to talk a little bit about implied domain. Mainly we're going to talk most about domain restrictions. We've done that a little bit in class, but I do want to talk about what the domain is. And sometimes when we do that in pre-calc, in some of our circumstances, we actually can almost identify the domain by the restriction itself. So it's everything but the restriction. Let's take a look though. In this first one we have discrete information, so it's all separate, and so our domain would need to be listed separate. So our domain in this case would actually be just -3. Of course, hopefully no domain is your x values. So -3, -1, 0, 2, and 4, and that would be our domain. In the second example, we know that there's a restriction here because in a square root you cannot have a negative. You can have 0 but no negative. So all the x values would have to be 0 or greater. I'm going to look at that. So they'd have to be 0, and they could be 0 or greater. I'm going to put infinity out here. It makes this easy when we're writing interval notation. So from 0 to infinity, because it could include 0, we'll put a hard bracket and a soft bracket, and then that would be what my domain would be. All right, let's take a look at the next one. The next one's a transformation. You know that this -3 is a horizontal shift, and it would actually go to the right 3, so at +3. So our graph would shift to the right 3. If you want to look at that square root graph, it'd be like this, and it would start here. So it'd be from 3 to positive infinity. So from 3 to positive infinity. The 3 would be our starting point, and it would be equal since we have an equality, so hard bracket and soft bracket. All right, rational function. Rational function. Well, let's talk a little bit about the domain here. We only have a problem. It's a fraction, and in a fraction, the denominator cannot be equal to 0. Okay, x could be 0, but the denominator itself could not be equal to 0. So you could think of it as x plus 5 equals 0. So x, if it were to equal 0, it would be -5. So x cannot equal -5. Often, you can get away with just writing the restriction, but let's take a look at what it would look like on a number line. If x could not be -5, there'd be a big open circle there. But it could be everything to the right and everything to the left. So negative infinity and positive infinity. So if we wanted to write the actual domain instead of just the restriction, then you would write negative infinity to -5, both with a soft bracket, and you would write from -5 to positive infinity, again with a soft bracket. Alrighty, let's go on to the last one of these. Now we got a little tricky one here, and so this one you're going to test. I'll do a little bit of testing on. Again, we have a square root, and we know that all the values underneath the square root have to be greater than or equal to 0. So we're just going to say 4 minus x squared is greater than or equal to 0. Greater than or equal to 0. I'm going to move the x squared to the other side, and I have 4 is greater than or equal to x squared. Now, I like to flip it around and put my letters on the left, so I'm going to rewrite as x squared is less than or equal to 4. I'm just following along with my inequality. And how would I get rid of a square? Okay, we'll be really careful here. So if you get rid of a square, you're going to square root. Again, you're an artist, so it's plus or minus. So x is going to be less than or equal to positive or negative 2. Positive or negative 2. Well, this gets to be a little more complicated. I'm going to use my number line. I have 2 values. I know it's equal at that point. I know it's 0 at that point at -2, which I could be equal to, and 2. I need to know, is the values between them going to make this true, or the values out here on the right and the left going to make it true? I'm going to start with the easiest point I can test, which would be right in the middle of them, which would be 0. If I plug a 0 back in up here, and I get 4 minus 0, I would have 4. That's a positive under a root. That's a good thing. I like that. Happy face. Now, if I doubt myself, I'm going to go ahead and test another big number. Let's just test 10. That would be on the right. 10 squared is 100. 4 minus 100 would give me a negative. That can't happen. So these two sides would not be good. My solution set would be right here in between. Oops. Wow. right here in, I don't like when I do that, right here in between. So if I wrote that as interval notation, I could just put a comma here. Because it was equal, I put a bracket, and there would be my solution. Go Bearcats. Okay, now we're going to start 1.5, so go ahead and write 1.5 at the top of your notes so that we know we're in that section. And these are the 3-column notes for 1.5. Again, you should be copying what's here down and then annotating and adding to your notes the things that I add, but also the things that you're being asked to do in them. All right, so we're going to talk about graphs of a function. They can be visually determined by, if it is a graph of a function. Well, we just talked about it. Visually, you can look at a graph, and if it would pass the vertical line test, then it is a function. Zeros of a function. I'm not going to work through these. I'm going to work through one of these with you, but zeros of a function are simply setting the function equal to 0. So making your f of x equal 0. F of x is the same as like making the y part 0. If the y value is 0 and you find the x value, you found your x-intercepts. X-intercepts and zeros, roots, are all the same thing. So you would take each of these equations, equal it to 0, and solve. Let's look at this last one together here. I want to talk about this because you don't think about this as often. There's a really simple way to do this, and you could make it a lot more complicated. But this is a fraction. So I want you to think off of here to the side, if I have 0 over 2, or I have 2 over 0, which one of those fractions is equal to 0? Hopefully you picked the first one. The second one is division by 0, which is undefined. But anytime the numerator of a fraction is 0, the entire fraction is 0. So if we want to find our zeros, all we're going to look at is our numerator. So we're going to say 2t minus 3 equals 0, and t then would be 3 halves. So my 0 would be 3 halves in this case. So don't make that more complicated than it is. We're almost done, just a little bit more. Next, I want to refresh your memory about increasing, decreasing, and constant functions. I have a graph here, and we just want to talk about it. Remember, this happens to be another piecewise graph. We're going to read these graphs going left to right, from left to right, just like you would read in a book. And as you move across the graph, is the graph moving upward? It's increasing. Downward, it's decreasing. Staying the same, it's a constant. So let's take a look. I believe from, and we're just going to say this is infinity, but I believe as you move this direction, the graph is moving upward, and so on the interval, let's say from negative infinity to 4, we'll say the graph goes on forever. From negative infinity to 4, the graph is increasing. Then from, negative infinity to negative 1. From negative 1 to 0, this part of the graph right here, it's moving downward, it's decreasing. From 0 to 2, the graph is increasing. And then again from 2 to positive infinity, the graph is constant. And I think you probably remember that, but I just want to go over it. It does become very important as we move forward. All right, the next thing I want us to talk about is the relative min and max. I have a really good graph here. It's basically the point on the function where the graph changes from increasing to decreasing or constant. So notice as it moves up, it's increasing, and all of a sudden it begins to decrease. That point at the top is your relative max. And it goes, it's decreasing, and then it starts to increase. That point right there is a relative min. Relative because it's relative to the graph around it. Not a maximum, not an absolute, a max or min, because an absolute would be for the entire function, the highest point or the lowest point. So there's a little bit of information about relative min and max. Next, we're going to get a little bit interesting here with our average rate of change. Average rate of change, the slope of a line through 2 points on a nonlinear graph. This line is called a secant line and is denoted by m subsecant. We talked about this a little before. It's basically the steepness of the line is that average, if it's an average rate of change. It may not be the change at that particular moment. We talked about that driving on a trip. Sometimes you may be at 0 speed, and sometimes you may be at 100, well, not 100, but 70 speed, but maybe your average miles per hour were 60 or 65. So on an average, that's what we're looking for, and this is the average rate of change form, our theorem right here. So here's the equation. It's basically the change in y and the change over the change in x, which is very similar to slope, but it gets a little interesting when you're talking about two particular points. from a function. So we're going to use this function, x cubed minus 3x, x cubed minus 3x. And I want you to notice something. Wow, let's see what that function might look like. All right, this is a polynomial function. It's positive. It's going to go up on the right. It's an odd function, so it's going to go down on the left, and we'll have 2 points. Since there is no constant, then they will have an intercept at the origin. So let's plot where from x is -2 to 0. From x is -2 to 0. So if I come out here and x is -2, let's put my point, if I go down and just say that's -2 right there, and then at 0. And I were to draw a line through that. I want to know the average rate of change of my graph. Now notice the graph is moving upward and then it's coming down. So it's not going to be a constant rate of change, but we want the average rate of change from where x sub 1 is -2 to x sub 2 is 0. So from the 2 points, the x value of the 2 points. So here's what we're going to do and plug into our equation. So we're going to have, just follow the equation over here. This says f of x sub 2. So it's going to be f of 0 minus f of x sub 1, which would be f of -2, all over x sub 2, which is 0, minus -2, which is going to become plus 2. Now, we're going to go up and use our function, and we're going to pretend like it's not f of x, but f of 0, which would put zeros in for these x's. So we would get 0 cubed minus 3 times 0. Then we're going to subtract. Be careful with the subtraction. I'm going to put a parentheses, and we're going to plug in -2. So we'd have -2 cubed minus 3 times -2. And then we're going to work through, all over x plus 2, which is 2. And then we're going to work out the math. I think that you can do that. This is going to, of course, be 0 minus, this is going to end up being a -2, and you're going to minus, this will all become -2. You're going to minus a -2, which becomes plus 2, and it's over 2. And so the 0's gone. 2 over 2 is 1. So your average rate of change on that graph from -2 to 0, the average rate of change is 1. All right, go Bearcats. One more little thing. You just heard me talk a little bit about odd and even functions. Odd and even functions have to do with their symmetry. An even function is symmetric with the y-axis, and an odd function symmetric with the origin. I have a typo there. F, that should be an F. Sorry. But there's a kind of a shortcut way to think of odd and even functions. An odd function contains only odd powers. An even function contains only even powers. And a function that is neither contains both. Odd and even. So if it has odd and even powers, like you have an x to the 4th minus, x cubed, and you have an even and an odd power, then you have no, it's neither odd nor even function. So that's just something to be important to have in your notes. It will come up. You will see it. The last thing here you want to write down is just another one of our the distance problems, equations that you're going to use quite a bit. This is when you're talking about acceleration, and this is just a standard formula that you'll use in a little bit in math, and particularly probably in physics. It might help you in physics. We both got the feet and meters to plug in for your acceleration constant, so whichever we are dealing with. So I think that's it. I hope you have a great evening, and beat Katie. Go Bearcats!